today I'll be teaching you about recurrent neural networks. Any idea so far? Any idea on RNN? Anybody?
Better learning, fast learning, a machine which is capable of doing everything that a human brain can. That is the reason that we are moving towards deep learning era, right? Like you as a student, you are moving your learning towards deep learning rather than normal other programming languages. Understanding? So that was that's the reason why you want to study more and more about AI. Okay? So the basic stepping stone towards that are these three. The basic pillars is what I can say is neural networks, CNN, RNN. Okay, remaining all topics that you have in this workshop, they are based on these three. They are fundamentals. Okay, so that's the reason you are supposed to study first ANN, CNN, RNN. Remaining all things become simpler and easier for you to understand and grasp. Okay, now I taught you which topic the other day? CNN. What was the need for CNN? What was the need for CNN if you remember? Computer vision as an application of CNN. Okay, and computational speed is high, efficiency is good, and what type of data? Mainly images or visual data also. In video processing also we will take the frames of the images and we will process. So visual data. Okay. Why for visual data only CNN? Because it deals with spatial dimension. What is spatial dimension? Because we are not only bothered about one pixel value and giving it to the network like a normal ANN does. We are bothered, like when I see at a picture, I am going to see the entire picture and get an information out of it. One pixel of that picture will not tell me it's a Bhagat Singh. I have to see the overall pixels and then my mind will visualize it as a memory or like it matches with so many people in my memory and then it will reflect as a Bhagat Singh. Clear? So that spatial dimension I am going to get with respect to CNN. And two major drawbacks I discussed of ANN with CNN overcomes. Do you remember that? Lack of spatial awareness was with the ANN. Spatial domain dimension came into CNN. And second, very good, like weight sharing. Okay, to cut down on the number of parameters that you're using for calculations, what you are doing is you are taking a concept called weight sharing. Okay, and then you are proceeding with entire CNN. So we are not here to talk on CNN, we are talking on RNN. So why do you study RNN now is what we are going to see. Okay. So this was a quick review. As I already used this slide at my CNN lecture, I am reusing it here. Neural networks, broadly fundamental concepts, ANN, CNN and RNN. We have seen two of them, ANN and CNN. Today's session is based upon the last one, which is RNN. Okay. Now, what is this? Everybody, you are aware of it, you do it daily. What is it? Google search. Actually, nowadays it is ChatGPT. Anyways, but Google search as a normal person, not as a technical person, any normal person will use. So nowadays you have this autocomplete option, right? So as in then you are typing one single character there, the results are varying. Are you observing them? Yeah. So my question to you, how Google's autocomplete feature works? Given a thought, it makes your life very simpler, right? How? It predicts. Yes, it predicts the next word. Understanding? So now, given a thought, have you ever given a thought how this thing actually works? Okay, way back, I also used my Google search when I did my engineering, but this option was not there. It was a normal Google search. I was supposed to type the entire sentence. Okay, but very soon we saw this concept. Then how is it happening? How is it search for like suppose I want to buy a bike and I'm searching on Google a bike, and suddenly all my Insta pages, Facebook pages, all my Google websites shows these pop-ups and new pages of the thing that I have searched or something related to that. In a few years I've been observing, right? How is this happening? I mean, it became antaryami, in Hindi we call it, the phone became antaryami, it knows what I'm thinking. It provokes me to buy it. Make sense? How is it doing? It is all AI. Okay, so it is learning what do you need and it is giving you the same. Understanding? So these three concepts of ANN, RNN and CNN are very, very important for you because you are into this era. Right? Now, so how does this Google's autocomplete feature work? So what is happening over here is, just try to understand how it works. There is a collection of large volume of most frequently occurring consecutive words. What consecutive words means? What comes after another. So you are giving a large volume, you are training a machine with a large volume of such words, and then it is given to what? Fed to a recurrent neural network, or the RNN, that we are going to see today. So what's happening inside backhand of that search engine? There's a huge volume of consecutive words with which the machine has been trained on a RNN. So with that, what happens? Your Google search is going to give you the autocomplete for the search that you have been doing. Clear enough? So one practical example I gave you why you must study RNN. It's a part of your day-to-day life. You may not realize it until you know RNN. Clear enough? Yeah. So these are some popular neural networks which I guess in session 1 we have already come across. Okay, so I am not going much into detail of this, but I just read it for you. Feed-forward neural network, convolution neural network, deep neural network, deep belief network, recurrent neural network. So these are one after the another with their overall applications. Alright, so now when I take the simplest one, what is it? Feed-forward network. Feed-forward network is a normal multi-layer perceptron network, for an example. Okay, now I just pick up this. Now what is the problem with this? Again now, go back to square one. I dealt with problem of ANN and then I told you why you must read CNN. Now same thing I am going back to square one. I will go to square 2 also, but square 1, and I am going to tell you what is the problem with your basic feed-forward network so that we have to upgrade it. Okay, so now you have got input layers, hidden layers, output layers. You follow forward propagation for learning and then back propagation, same what you have learned so far. So what is the problem with this? Okay, so in this feed-forward network that you have been dealing so far, decisions are based on current inputs, alright, and there is no memory about the past. Right now what you are giving? I am giving you the output. So it's like an ATM card. You just put an input, it gives you the output. It is not going to remember your previous things and tell you about your denominations that you may try for future. These days though it is also upgraded, but I am just telling you conventional ATM. Okay, so now there is no future scope for it because there is no memory associated. If you want to do few better things with it, you can't go for it. I mean, to a higher end application, you may not be able to use it. You have to upgrade it. Like how we upgraded with CNN. We have used an MLP. We have used a multi-layer perceptron, but we prefixed that with something that could benefit us with an upgradation. Clear enough? So now the time has come now to upgrade again in terms of what is our application. Okay. Now, what is the motivation for RNN? Okay. So I am going to discuss here about two networks which you have learned so far. Okay, feed-forward network and convolution neural networks. Why we should leave these, or I can say we can upgrade this to something else. So what is the motivation for RNN? So as we discussed just now, feed-forward neural network has got certain limitations. Could you read that for me, please? What is the first one? Good. It is fixed input size, correct? Second, lack of temporal information. If you have got time as one of the dimension, okay, if your data is dependent on time, your data is in a layman's language, if it is sequential, then it's a problem with feed-forward network. Then curse of dimensionality. Number of parameters will be increasing a lot. Okay. Then limited context. So these are all the drawbacks of your feed-forward network which compel us to upgrade it. Now basically if you are going for data like your text messages, okay, you are very good pro at chattings, right? Now if I ask you some question, you would just highlight that in WhatsApp and put a dot. You go back to that message, you go back to that message, refer this, refer that, yes? So doesn't your system require a memory to interpret what you exactly want to say? Is that possible with a simple feed-forward network? No, because eventually there is no memory. So interpretability will become difficult. So there's a need to upgrade. Okay, clarified. Now the second part. The second network that we saw so far was CNN. Now CNN was very good when you had a data with a spatial dimension, wherein if you want to extract features or information, your data must be whole and soul dependent on the spatial features. You are not bothered about how it is dependent on time. Understanding? So if there is a sequence again, and if you have a data which is based on some position, which is based on some order, which is based on some time in other way, if it is sequential in nature, then at the time also you cannot work with CNN. Okay, so that's what I mean to say here. CNN cannot process natural signals that have temporal dimension, which is based on time. Okay, now along with the spatial dimension, such as some examples are audio signals, like what I am speaking here is also a function of time. Every second my voice is changing. Sometimes I am too loud, I am too low, I am murmuring, there is a noise. So every fraction of second there is a change in the intensity of my voice. Okay, so a signal is nothing but, what is it? It's like it is based upon two dimensions. One of the dimensions will vary with the other. So here my voice, the power in my voice, the intensity of my voice is varying with respect to time. Understanding? Right. So speed signal, the text we read, the stock market that changes over the time, all of these are like temporal data. They are sequential data. So they require something else also. What is that else that I am talking about? What else you require if you want to extract temporal information? Memory, very good. So you require certain system with a memory. Okay, so that's the reason we are here today to study about RNN. Exactly. So what is this solution to our feed-forward network if I take the square one? The solution is a recurrent neural network. Before I actually dive into the architecture, which is quite deep, the left hand side is the simplest representation of RNN that I can give for you. Okay, the left hand side diagram. What do you think is happening over there? Just try to understand and analyze. No bookish knowledge needed. Just try and see what is happening. See, normally if I take any system till now, I was giving an input, there were some layers in between, and there was an output, correct? What is special here? The loop. That loop is nothing but what? There's a feedback. What do you mean by that feedback? There's something of present which you are giving it to the next. Yeah? So what are you doing in a way? You're giving a memory to your system. Clear enough? So that's the simplest diagram I can give you for recurrent neural network. So solution to the problem that feed-forward neural network had, the solution is RNN, and how does it solve it? It can handle sequential data, it can consider the current input and also previously received inputs as well. Okay? And then it can memorize previous inputs due to its internal memory. Clear enough? So by these three things, RNN is going to solve the problems that we face when we used only a simple feed-forward network. Clear enough? So if I can say, if I ask you something like, out of these two hands, which one is important? Can you choose? Both of them are important. So same, in a similar way, the feed-forward neural network has been extended by CNN on one hand and RNN on another hand. Both of them are important based upon the type of data that you're working with. Clear enough? Yeah? Some applications to just draw your attention, why the hell in morning 9:30 I'm supposed to study this topic. Okay, so you use it every day, right? Why you should learn about it? Let's see some applications so that you understand what is going on. Okay, so the first thing, what is it? Time series prediction. What diagram that I put it on? What picture is it?
Stock market.
Stock market. Okay, so stock market prediction, nowadays people earn a lot. Just I also know people who just share the WhatsApp groups and say, we'll give you tips for stock market, this thing you have to pay us so and so. Okay, so this prediction is actually, it's like a very lucrative business these days. Okay, so your time series analysis is also dependent on RNN. Why? Because stocks change with respect to time. Okay. What is it? Today's session also, like today you have one session on it. What is it? NLP stands for Natural Language Processing. Okay. So, aajkal to chhod do. When I was in college, if there is some new movie release, I would ask my friends who have seen it, like, how was the movie? How was the movie? I would ask for a person and then I would invest on the ticket to go and watch. Aajkal karte ho? What you do? IMDb ratings. Yeah? Google search. How's the movie? IMDb rating greater than 7 at least. Okay, worth watching in theatre. Otherwise, let's wait. It will come on OTT. Yes or no? How many of you do that? Almost everybody. Okay, so now that's how. Text mining and sentiment analysis. Now, the reviews which will be given for the movies, based on that, you will find out if that movie is good, bad or average. So that is good. That is a very helpful tool. Who is doing that for you? RNN. Okay. NLP also majorly uses a part of RNN. What is it? Image captioning. I need not tell you again on that. You are very good at it. Image captioning. Okay. Now, thanks to social media generation, this is very popular these days. Next. What is it? Machine translations. You are a very lucky generation, I really feel. Because we used to study volumes and volumes of books to get information. For you, it is just a click away, thanks to that extent of internet and era that we are living in today. So even if something is in Japanese and Chinese also, you just press one button over there, translate. Yes or no? Netflix also. Many languages available. You just put translate. So its tasks have become very simpler. For you it is just one click. But backhand what happens? Have you ever thought about it? How this simple cell phone is doing all this translation? So you have to provoke because we are technology people. We have to think. Okay? Right. Now, coming to the meat of the seminar, what is RNN? Okay, so RNN stands for Recurrent Neural Network. It works on the principle of saving the output of a layer and feeding it back to the input. in order to predict the output of the layer. So till now, whenever you were drawing those block diagrams of the architecture, it was always the arrow marks towards the front end, towards the output, right? Now there will be also one arrow mark from every layer which will be going back to the previous layer. So in a way, you are reutilizing your output that works as a memory for you. Okay, so the simplest diagram that you can put on over there is a recurrent neural network. It is actually what we call as a folded RNN because the output is coming back. Okay, now that's the simplest difference that I can give for you. Could you make out? The left side is a normal feed-forward network versus the right side is the RNN network. What's the only difference that you could figure out? There is a red mark over there on the right side. What is it called? Recurrent unit. So that feedback is what changes the game. Clear enough? Looks very simple, no? But architecturally it is very, very complex. We will see that also. Okay. Okay, are you interested? Shall we go ahead and see what makes it, like how that memory comes? You already know what is memory, but how that memory comes, it is very interesting if you just put a little brain of yours in this. Okay, now, if I elaborate that folded recurrent neural network, the architecture is something which looks like onto the right side, the picture that looks like. So what is happening over there? I don't know if the last of you can actually visualize it, but I'll read it for you. What is happening here is in the central node, you have x of t, there's a hidden unit h of t, and out of that is what you're getting output y of t. So it is down and up. Downside there are inputs and it is passed through the hidden unit and then you are getting an output. So what we are working here is with three terminology: x of t, h of t and y of t. X of t is your input, h of t is your hidden unit and then y of t is the output. Now that is the middle part. Now if you can see this particular area, what is this? This node is now written as h of t minus 1 and this particular node is h of t plus 1. Same way with the notation of input x of t plus 1, x of t minus 1. Same is with the notation of output y of t plus 1, y of t minus 1. What is this plus 1? What is this minus 1? Whenever for a temporal data, for a time-based signal, if I am adding a minus 1, means I am delaying that signal. Delaying means one step back. When I am adding a plus, it means I am advancing that signal. That means a time step ahead. So what are you doing here? Where is memory now? Which of these notation will refer memory? Memory is always past. है ना? Memory is always past. Then what is ahead? Prediction. Correct? What is going to happen next? So that y of t minus 1, y of t minus 2, your previous outputs are your memory that are given to the next unit to predict your next output. So that's how you have a minus 1, that's how you have a plus 1. Clear with this? Where we use a minus 1 notation, where we use a plus 1 notation. Wherever you are using a minus, it means it was past and it is memory. Wherever you are using a plus, it means you are going to predict, or that is the future output out of it. Clear enough? So you can see all of them are interconnected. My current output is dependent on my previous output. And my prediction is also based on not only my present, but also my past. Clear enough? Clear with this basic diagram? Yeah. Right. So everything everything, whatever we are assuming, whatever our thoughts are, unless and until you can put that into mathematical model. Okay, it should be there stochastically. There should be a mathematical model. Until then, you cannot write your logic. Yes or no? So even if you are writing something in Python, you have to think about it. If I ask you, find out how many of your friends have scored less than 70 in my subject. So what you will do quickly? You will write a for loop. You will say if n is less than 70. What is that? Less than? Mathematical operator only, no? So every logic requires a mathematical model. Correct? Okay? Then only you can begin logically over that. So for the same thing, if I want to put down mathematically RNN, then how am I supposed to put down? Okay, so this is how I am supposed to put down RNN as, wherein what I am calculating now is very, very, very important, and my terminology is also changed now. Am I calculating next output? No. I am more bothered on this one term that I will use from now onwards, which is called state. State. Okay. So this state, now I am not calling it as output. I am just calling it as state. Why am I using this? Because to get an output, I have to pass through so many past and present values. So every current value that I have in that one layer, with so many layers existing, is my state. Okay? This state has to be fed back to get the next state. Understanding? Everybody? Are you clear? So my aim here is now to find out the next state. So notations are important because if you don't understand this now, the remaining part of the architecture becomes waste. Okay, so the next new state that I am going to calculate, I write it with HT. Okay, now why that T? Because my data is a sequential data. It is based upon time. And I am talking on only T. Am I writing HT minus 1? Am I writing T plus 1? Then what is HT? Very good. It is the present thing that I am talking now. So when I am talking, it is now, then what it is based on? What happened? Today's class also, I began with AN and CN and I refreshed your memory. What did we do in the past? Then only we began today's session, right? So the same thing. When you want to find out the new state in an RNN, it is a function. It is always a function. Something you are doing. What you are doing, we are not bothered. Okay, it's a function of present input that I am giving and past state. So today also when I began my session, I gave you a past history of ANN and CNN only on application specific. I didn't move into how it worked. Okay, so that state I have picked up and I have used today's data. What was it? How does a Google search work? And I tried to correlate both of them. Understanding? So everything is like how you are doing. What you are doing right now, I am not teaching you. So that function here is dependent on two things. One is what is the past state? Past se kya aaya? What came inside with you today? And then what is today's input that you have got? Clear enough? So this is a very, very powerful equation you have to understand. Okay, so you are calculating new state, which is some function with certain parameters. Of course, if it is a neural network, the parameters are supposed to be weights. Okay, so there are some parameters which are involved in that function, and then it's a function of old state, and that at that time step, what is the input? Input vector. This term I have used. Now, what is vector? See, when you are using terminologies, you should always see why. Why is something called as like that? Okay. So I could have just put it with an input. I use the term there, vector. What is it? Direction. Vector is something that has got magnitude and direction. like वो maths का definition. हाँ, now coming to computer science students.
It's a matrix.
Matrix data, very good. So when you have a data with a dimension, okay, you treat it as a vector. Okay. Now, generating sequence of vectors. That's what we are going to learn before we actually dive into RNN, because of the term that I use there. My input is not a normal input. My input is a vector. Why do you require this vector? Does computer understand the normal language that I am speaking to you, or the normal text data that I give it to him? No, right? It doesn't understand. What does it understand? Binary data. So now I have one word. A word now that I am speaking to you, in my vocabulary, whatever I am speaking to you, is my every word fixed word length. So the same way when you text your messages, it's varying, right? Your data is varying. Your data is dynamic. Your data is not fixed. Okay? So every text or every sequential data that you are giving to your machine should be understood by a machine in a proper way. How does it understand this? By converting that data that you are giving, any sequential data, into vectors. So that's the reason I am going very little on this, because I think maximum of it will be covered in NLP. A little brief, because since I have to teach you how RNN takes. Okay, now generating sequence of vectors. A sequence of vectors is a fundamental input format when you are using RNN, and it is commonly used for tasks involving sequential data like NLP, time series analysis, speech recognition, genomic data analysis, etc. Genomic data, DNA sequencing and all. Okay, so with all of those things, you require input into a form of a vector. Okay. So, vectorization is nothing but each element in the sequence, which could be a time step, which could be a word in a text, which could be a frame of a video. Okay, all of these will be represented as a vector, and these vectors will be created using various techniques depending on the type of the data and also application. Now, I am not going much in depth. One such is one-hot encoding. I guess you must be aware of it. One-hot encoding, because you are already studied machine learning and coming to me. Okay, so I am assuming you know one-hot encoding, right? One such way is one-hot encoding, and the next is word embeddings, which we will use, which I have used in today's case study. Okay, word embedding. So there's always an embedding layer before you actually progress towards RNN. So what is this embedding layer doing? This embedding layer is converting your sequential data, whatever you are giving, into vectors. Understand it? So now word embeddings, the words are often represented as dense vectors. You can either go with a whole and soul programming of embedding layers by scratch, or because I told you, you are living in a very lucky era. So everything comes very easy also. So you have got pre-trained word embeddings also with word-to-vec, globe or fast text. So what are you doing in that? Remember my first slide? What we are doing in the first slide? We are taking huge volume of consecutive words, right, and getting it trained. So these are all readily available. All these words and their vector forms. We are just downloading that and using it in our case study. That's the reason I just wanted to give you a hint on this word embeddings. Okay. So what I am doing essentially here in today's case study, I am not going to do everything manually. I am just taking pre-trained vectors and I have started working on my data set. Clear enough? Now, each word in a sentence is replaced with its corresponding word vector, and the sequence of vectors is organized into input tensors. What is a tensor?
Multi-dimensional vector.
Very good. When you are working with high amount of data, you require multi-dimensional vectors, which helps you to ease your computation. Computation should be very, very fast. Okay, so each single unit is called as a tensor. So your word will be converted into vectors. Again, it's a huge dimension. You want it to be in the form of tensor. So automatically these pre-trained vectors will give you your word in the form of tensors. You can use it through your suitable libraries, okay, and then work on it. Clear enough? Yeah? Now this is the basic RNN architecture of a basic RNN. 3 layers, okay. What are they? First one, input. Second one, hidden. Third, okay. So the input layer, this is the layer where the sequential data will be fed into the network in the form of vectors. So before this, I come to this, I should be working or writing a code for converting whatever data set you are dealing with into vectors. Okay? Embedding has to be carried out. Now, the second layer is your hidden layer, which we also call it as a recurrent layer. Recurrent. It is sequential in nature. Whatever is coming out is also going in. Okay. So now in this recurrent layer, it will process the sequential data. It will maintain a hidden state. Okay, I'll be using this term more often from now onwards. Hidden state. What is hidden state? There are multiple hidden layers. Every layer has got a hidden state, which will be passed on to the next as well as to the, okay. So we are going to work a lot on this hidden state. So it maintains a hidden state that captures the information from the previous time steps. And the common choices when you are coding will be to use the type of RNN. Okay. So there is a simple RNN, of course, and then you have got choices for recurrent layer as LSTM and GRU. Okay, LSTM stands for long short-term memory. What is it? We will see. And GRU is gated recurrent unit. Clear enough? So embedding layer is over, and then now we are moving on to your basic RNN. In that you would choose what type of recurrent layer do you want? Simple RNN, LSTM, GRU. Okay. This is the output layer, which is going to
give you the final predictions or the classifications. Okay. Now, how does an RNN work? Okay. So, at each time step, an RNN will take the current input and also what? And also? So, how many inputs now you have at every step? 2. The present input and then the past hidden state. Okay, the past layer output. So, past layer output, I am now in my terminology calling it as a hidden state, the past hidden state. It will update its hidden state, means whatever layer you are working on, it will also update its state and then it will pass it on to the next layer. Clear enough? What am I calling as output? Hidden layer I am not calling output, I am calling it as a state. Output is the final prediction that you will get. Okay, clear enough? Now, the updated hidden state is then used in the next time step. So, this is the flow, how we are working with RNN. Again, as I told you, this is the mathematical representation, a little twisted. Okay, so what did I write now? It's a function of h of t minus 1 comma x of t. Clear? Why it's a function of h of t minus 1? What is h of t minus 1 here? The state from the previous hidden layer. And what is x of t? The current. So with that you must understand there is always a new input coming to every layer. There is always a previous output coming from the subsequent layers. And then I am finding the output to the next layer. Understanding? Clear? There is a continuous input coming. There is also input from the previous layers, hidden states, previous hidden states. And then I am finding the next hidden state. Okay, don't get confused. Now, this recurrent process will allow the RNN to capture dependencies and also the patterns in your sequential data. There are 4 types of RNN that we have to see, like based on the application, what category of RNN could you use? There are 4 broadly, one to one, one to many, many to one, many to many. What am I talking on? What am I talking on this? One to one, many to many. What is this? How many inputs? How many outputs? As simple as that. So, the first one is what we call the conventional or the vanilla RNN. It is 1 to 1, which means it takes single input and takes single output. Okay, you could see it is used for all general machine learning problems, which is based on only single input. It is going to give you an output, single output. Could you list me one? One machine learning problem which uses single input, single output. Very simple. Regression, of course, yes, good. So, problems like that are going to make use of one-on-one RNN, okay. Second one, one to many. One to many, as the name suggests, single input and multiple output, okay. The application example is image captioning. Single image you are giving and you want to categorize it into multiple outputs. You are going to give the sentence, like the picture that I showed you, the cat was sitting on a road. So when you got a single input, but you got multiple outputs out of it. That's the entire sentence, okay. The third one, many to one, you have got multiple inputs and a single output, okay. You have got very good example as sentiment analysis, like I have seen that movie, it was paka waste of time. I am giving so many words as my input. What do you infer out of it? Good movie, bad movie? So, got it? Multiple inputs and single output. Next, the last one, many to many, multiple inputs and multiple output. Chinese to English translations, for an example, machine translations. Okay, multiple inputs you are giving, a lot of words in that sentence, and what you are getting is also a lot of words in that particular sentence, probably in some other language. Okay, so machine translation is a brilliant example for it. Now, how do you train an RNN? Now coming to the core part, guys, a little bit boring, but you have to understand. Okay, now training an RNN involves forward and backward propagation, but due to recurrence, RNN has got time dimension, and that has to be considered when you are back propagating. So learning from that network is very, very complex now. Looks very easy, lot of nice applications. The more simpler it looks to you, the more complex it will be in the architecture. It is always like that. Okay, the more simple the architecture, the more headache it is of the coder. Okay, the more simple it is for the coder, the backside the architecture is very, very complex. So same thing here goes with RNN. Now you have to even consider the time dimension, how it is going back in the back propagation. Now the techniques like vanishing gradient problem can affect the training. Now what is this vanishing gradient descent? Very quick, refreshing your memory. Gradient descent, what does it do? Updates the times, the step of your gradient, and the machine is going to learn from it. Sees where it is converging, and then it is going to learn from it. So what happens is, because of this vanishing gradient descent problem, what is it? It means the gradient, while it was descending, it became so small that hardly it makes any update to your system. So this is what we called as vanishing gradient descent. And opposite also exists. We call gradient explosion. That means when the gradient value goes by far 1. That's why, we want it between 0 and 1. So there are two problems, gradient descent and gradient explosion. So what we are mainly focusing here is on vanishing gradient descent. So what is going to happen with it? Why simple RNN also had to be upgraded, that we are going to see. Okay. Now, why LSTM and GRU have to be studied? This simple RNN which I taught you also, the simple architecture, you know, that folded RNN, that was also not worth. Why it had to be upgraded? Why? Because limitation was it underwent vanishing gradient descent problem. Like as I told you, gradient became so small, learning was not possible. Okay. Now, I already explained you this. Gradient is nothing but, gradient update rule is new weight is equal to weight minus learning rate into gradient. So what happens is, during vanishing gradient problem, during the back propagation through time,
I will screw the architecture now. I will mold a bit to just make sure that there is ample memory inside it. There is no vanishing descent problem in it. Okay.
Okay. So now for that, as I told you, there is long-term sequences and there is relationship between each and every sentences which RNN could not retain. This was the reason of failure. What is the solution? LSTM and GRU. Okay. That's the reason now from ANN we went CNN, simple RNN. Now what we are studying? So there is always a why. If you know the why of your life, you are successful. Okay, so this is the why you are here for today's session, LSTM and GRU. LSTM and GRU work with gates.
You have studied in your first and second years, right? Okay, digital logic design, you know, you work with gates. Gates. You had the subject of computer organization. You studied about memories. What is the fundamental unit of memory? Flip-flop. Familiar? How is a flip-flop made? Have you ever seen a structure? Works with logic gates. It is suitably made with logic gates, and that helps you to retain memory. So wherever you want a memory, what do you want in your architecture? Gate. Something that works as a gate. Opening, closing. Opening the gate, allowing it, closing it, retain the information. Clear enough? So now here also in the architecture we will use the concept of gates to work with memory. Okay. So now you can regulate the flow of information using LSTM and GRU. You will
Recognize which data is important. Now again, important part. It's not only important that it predicts you with the previous memory, it is also important computationally it is very, very fast. So what to do? Will you remember this 2-hour lecture throughout your life? Word to word that I say. What you will remember? Some important points which you think are viable to you. Okay, for her if it is CNN more, she will work towards memorizing more CNN ka concept. You will work with RNN. So it's like what is important to you will matter. So the same mechanism have to be built here. Okay, there will be lot of corpus, but in that what is viable to get your prediction? That has to be taken forward. What is nonsense have to be kept aside. Okay, so your machine should be now working like your brain. Okay, now as I told you, application of LSTM GRU also, you will use it in speech synthesis and recognition, text generation and caption generation. Now, this was what I was talking. There's a sample. How do you determine to buy something online? These days we all do online shopping now. First thing that I personally go on Amazon and I see the reviews. Will I see every paragraph and everything that they write it over there? No, Baba. I'll just see the caption. And I would search for some words like what? Good, best, worst, average. Hai na? Some basic things. Remaining things I am not even bothered to study. So same thing here. Okay, you will subconsciously remember important keywords like amazing, wonderful, definitely buy again, and then only this looks like a good product and I am supposed to buy it. Okay. Now, remaining all sentences are gone. This 3 words say for the first review says amazing, the second one says wonderful will be carried out. And what will be my prediction in my mind? It's good to invest here. Okay, so that's what you are doing here in LSTM also. So now, when recalled, you would remember all the keywords and then definitely you will come to a conclusion and give your feedback. That's what a LSTM and GRU are doing. They will keep only relevant information and they are going to give you prediction. Why this is important? Word to word if you do, it is very difficult. It is going to be lot of time and cost consuming thing, even if you are using big GPUs also. So that's the reason you are supposed to identify the keyword, which word has to be retained into the memory, which word has to be deleted, and then you will be following it up with your next prediction. Clear enough? Now, LSTM is an artificial neural network, artificial recurrent neural network, which is used in the field of deep learning. Unlike standard feed forward, they have a feedback connection as well. It can process not only single data points like images, but also the entire sequences of data such as speech or video. Clear enough? Now, the application of LSTM is towards the task such as handwriting recognition or speech recognition. LSTM networks are modified versions of RNN which will help you, to make it easier to remember the past data in the memory. It makes easier to remember past data. How? You are not remembering entire past data. You are remembering only important things. Okay. Now before we actually dive into LSTM, let's see how RNN works. So what is happening over there? What are those green marks that you are seeing over there? Green blocks. Inside the layer, what is happening? I told how many inputs are going. How many inputs are going, I told? 2. What are they? The current input and nobody asked me what is current input then. Chalo, previous to TK it was prediction from the previous hidden state. What is this current input? Current input every time. What you are giving. So that's what we will see here. Okay. So what is happening here is I told you the words will be transformed into vectors. So you are seeing the transformation. This box of cereal gave me a perfectly balanced breakfast was a sentence that I got from one of my reviews from Amazon. Okay? Now these words, these are nothing but your inputs. They have to be given. They are your current inputs. And out of that, you have to analyze whether it is a good feedback or a bad feedback. That will be your output. So this gave me a perfectly balanced breakfast to your brain. Now the output is there. It's a positive statement. It's a good feedback. Okay. But how does the machine analyze it? So every time these words will be converted into these vectors. Can you see down? I have converted all the words over there. I have represented there as a vector for ease of understanding. So every single word will be given as a current input in the form of a vector. And previous thing will also come into pattern, because if I just say at the end, I just understood breakfast, it is not, I cannot give any prediction. I should take from that sentence perfectly balanced breakfast. Then it will make sense to my prediction. Clear enough? So that understand, perfectly balanced is coming from the hidden state, breakfast is coming from my current input, and I am going to predict what it is. It's a good review or a bad review kind of a thing. Clear enough? Now, so you could see this more elaborately here. This black point that you are seeing is a hidden state. This is one cell, what we call here, one LSTM cell, one RNN cell, because I am just teaching you RNN right now. This is one RNN cell and there is this hidden state. Then what is happening here is a tan H function. Why am I supposed to use tan H only? Tan H is a squishing function. It will help you to maintain the gradient value below 1. Gradient vanishing, if you are taking care, you have to even take care of gradient explosion also. That's the reason tan H activation function. Okay, inside every cell. Now, as you can see, to this cell, one input here is coming from the previous hidden state, one input is coming from the current input, which is one word, and then both of them are given to a tanh activation function, and then what will be calculated? What will be calculated? What is the output of this cell? Anybody telling output? Next state. Clear? Yeah? Next hidden state also, because there will be probably more subsequent layers coming into picture. So the information vector will undergo various mathematical transformations in this process. Because some of the values can explode, it is better we choose to pass them through an activation function to regulate the values of those vectors. And that activation function is nothing but a tanh function. Right? Next. Now let us see LSTM. Ab LSTM mein what is the requirement? I cannot use the same previous cell because I told simple RNN is ineffective still. है ना? Why it is ineffective? Because it has only short-term memory. It cannot retain long-term memory. So what is required here now? How that cell should be modified in that architecture? There should be something that should give you a memory. What gives you a memory? I discussed. Again, gate. Okay, right. So now, STM, here you can see you have, apart from those black and blue dots, some red dots. What are these? We will see. Using gate cell states is what an LSTM can work with long-term memory. So you can see here, this is the better picture of the architecture. Okay, so what you could see here are input gates, there are output gates, there's a forget gate, and then there's a cell state. Sorry. Okay, understand? You are understanding what is happening, why the cell has been changed so much. Okay, there's an input gate, there's an output gate from where you will get your next hidden state. Then there is a forget gate. Okay, what are all these we will see. So what is happening here is information gets added or removed via this gate. Added bhi chahiye, removed bhi chahiye. Why? Because I told you will not retain the entire information. You will retain only keywords. So that's how forget gate comes into picture. You will have to realize which of it is important and has to be retained and moved forward. Which one has to be discarded here itself. So there should be an inlet, there should be an outlet. Okay, and there should be some memory. Okay, what is that memory? Next, like present state going to the next state itself is a memory. Okay, now gates are trained to learn which information you are supposed to retain or discard. Sorry. So now gates are clear. Then what is this cell state? How many outputs can you see over there are going? Now what is the change that you could see? There are two arrows coming out of those cells. है ना? So what is one more thing that has come apart from there? Cell state. So what is this cell state? This cell state is actually working like a sequence highway which will transfer the relative information down to sequence chain. So there is a forget gate which will help you which information has to be retained. So your retained information has to be passed on, na? Isn't it? So for that what you need is a cell state. Then what information you informed from my current input, that also has to be passed on. So for that is the two arrow marks. One of the arrow mark in that output is giving you the previous information which was extracted and it has to be retained and given forward. And I also have my current input. What do you infer out of it? That prediction will go to the down arrow mark. So that's why there are two arrow marks coming out of that cell. Okay, so the cell state is like a sequence highway. It is nothing but memory of your network. It is going to transfer the information from previous time steps to the next time steps, and then it will reduce the effect of short-term memory. Presence of this cell state only will help it to retain the information which was in long term. Okay, so that makes GRU very different from a simple RNN. Okay, sorry, LSTM and GRU both. Now, as I already told you, now that you have got two outputs, okay, the entire hidden state that we were studying so far, single output, is now bifurcated into two. One is the cell state, another is the actual hidden state. So the cell state is nothing but the internal memory that is being carried forwarded, and hidden state is what you are predicting now, for which you will calculate the final output. Clear enough? What is cell state? What is hidden state now in LSTM? Okay. Now, so what do you think are these? You are seeing these red dots. Blue, black, I clarified. What are these red dots? What are these red dots? No. It's an activation function. What is it? Gates contain which activation function? Sigmoid. Okay, so it's important. Why? Very good. Because sigmoid output is nothing but 0 and 1. You have to tell to a network, you have to forget this particular state that you are coming across. It is waste, because it's like a, and, the, those. When you have word called amazing, you have to lock it. Okay, so you need your gates to be there. And gates on, gates off. So you require a 0, you require a 1. That's the reason which activation function you will use while designing this? Sigmoid. Clear enough? Yeah. So a network learns which data to remember and forget using this sigmoid function. Now, forget gate. As I told you, forget gate will decide which information has to be kept, which has to be thrown away. Closer to 0 means forget, closer to 1 means retain it. Example, how forget gate works. See, Mark is a good singer. He lives in California. Jacob is also a good singer. So now what is happening here? Mark is forgot. Subject is now changed to Jacob. So next subsequent sentences mein what it is going to speak and predict about? Jacob. So here which gate is functioning? Forget gate is functioning. Clear? How forget gate is helping you in this text prediction. Yeah? Now, what is this? Input gate. So what does an input gate give you? It will update the cell state, the previous hidden state and current input state, which it will decide the next hidden state that is coming into picture. What is important here is to analyze that it will be it is updated by transforming the values between 0 and 1. 0 means something which is not important and 1 means something which is important, and it has to be carried forwarded. Clear enough? So cell state, I told you, it's a memory. Kisko rakhna hai? Whom you want to be there, whom you want to remove. So this is going to regulate your cell state. Next, we multiply all of this again with a tan h function. Why again? Because I told you, we don't want a vanishing gradient descent problem. That's the reason again a tan h activation function we are utilizing. Now, cell state is multiplied with a forget vector, which helps you to retain or drop an information. The output of the input gate goes to a polarized addition, which will update the cell state to the new value. This is what I just discussed with you. Now, yeah, this is the last one. What is it? More of theory now. We are getting bored. We'll simply dive into our case study now. This is the last thing that I am discussing. What is it? Output gate. So what does an output gate tell you? It decides what should be the next hidden state. Okay. Now, the new hidden state and the next cell state are then passed down to the next time step, and tan h output and sigmoid output are multiplied to decide which information has to be kept, which information has to be retained, and finally we give our next hidden state as an output from this one cell of LSTM that we are discussing. So now prediction, where does this help? Jacob made a debut album which was super hit. Congratulations. So it predicted how? It retained Jacob, it retained debut album, and then congratulations prediction mein will go to the subject Jacob. So what has to be retained, what has to be forget. So it will be helpful in prediction. This architecture has simplified your long-term predictions as well. Now, computationally again LSTM was on the higher end. There were lot of gates involved. There was huge architecture which was going. So things were made to simplify that also, and the resultant was a GRU. Okay. So GRU was invented in 2014. It had only 2 gates. What is it? Reset gate and update gate. So this is very simple. When you see the architecture, it is similar to the forget and input gate. It will decide again which information has to be retained, which has to be discarded, and that's the cell. It is very simple when you compare it with an LSTM. I am not going much in GRU. Okay, I am just giving you an overview. We are not going to dive into architecture. Lot of theory will blow you mad. Okay, now advantages, very important. I told computationally GRU is more effective. Then what it should have? It should have a fewer tensor operations. Okay. Now they are faster to train. Now which one is best then? What should I take? An LSTM layer or a GRU layer when I design my case study? It's based on your application. Okay. So that's what we are going to see. There's a used case. IMDb data set. IMDb data set means movie review. Okay. So IMDb is a readily available data set in Keras that I am going to download first. Okay. And then it's a data set with 25,000 movie reviews from IMDb, and of course the labeling will be positive or negative responses. So what you must do first, before I work with RNN or LSTM or GRU, what I should do for all these reviews that I get? Reviews will be in the form of sentences. What I should do? Convert it into vectors. So these reviews are already pre-processed. Okay. And each review is encoded as a list of word indexes. Can you see over there? Okay. There are list of word indexes. If has got 1, U has got 14, like that. Word indexes are already, this is a pre-processed data set that I am taking. Okay. Just to show you how basically an LSTM GRU model works. Okay. Now, we begin by importing basic libraries. So what do I need? I require a sequential package. Then dense layer I would need. Why do I require dense layer? Because at the end again I am doing classification, whether it is a positive movie or a negative movie. So I require a fully connected layer there also, dense layer. And then I am using LSTM. Why do I use a flattened layer? Flattened layer because again you have got vectors which are coming as an output, but you have to give it as a one-dimensional vector as a column to the fully connected layer if you want to classify it. So flattened layer you will be importing, and then I am importing one more very important term there, embedding. है ना? It makes your task easier. You don't have to design your embedding layers which I taught you. It's already readily available. You are just taking it out of it and giving your data set to it. Okay, so I am importing embedding, I am importing sequence, and I am also for visualization using matplotlib. Okay, now I create my training data set and testing data set from the existing data set that I have downloaded. Okay, so you can see I downloaded as my first sentence import IMDb. It's a readily available data set in Keras. Right. Now I can perform padding. It's optional, it's up to you. Why should I do padding if I want all the sentences to be of the same length? Then I will go for padding, otherwise I may skip. And then I will build a model. Look at how am I building a model. I am first giving what should be the vector length, how my words should be, of what length it should be. and then I add what to my model? I am adding an embedding layer. Why very first I am choosing embedding, guys? Because your data is not understood by the machine. It has to be embedded into vectors. That's the reason first embedding. Then if you think that this may overfit, you will use dropout layer. I already discussed dropout layers with you. Then what you are using? LSTM. How many cells of LSTM am I using there? 32. LSTM cells I am using. And then I use at the end a dense layer for my classification, whether the movie was good or bad movie. And then that's it. Dropout layer at the end also, again, if I find it overfitting. Now, have a look. This is my analysis of the LSTM model. What loss I am giving there? Binary cross entropy, again binary. Why? Good movie or bad movie. Okay, 2-level classification. Optimizer that I chose was, why? Because it adds momentum while I am back propagating. Okay, next is what? Metric is what again? Accuracy. So you could see the total number of parameters. There you go. The moment I passed this data set, embedding layer is giving me how many parameters? How many parameters? 64,000 parameters. And by the end I developed my model, how many parameters am I working with? 257. Yeah, makes sense? The role of LSTM you are seeing over here. How much you are forgetting, how much you are retaining, and then what you are processing. So number of parameters have been reduced a lot. So you could see here, when I compile this particular model and I check for the accuracy, I have plotted here 2 graphs, same accuracy versus epoch, loss versus epoch. So what are you thinking? What is happening to accuracy? The orange line is validation or test accuracy. क्या हो रहा है यहाँ पे? What is happening? Is it increasing or decreasing? Had I not used a dropout layer there, then what will happen? Training accuracy was going high, testing was coming down, overfitting was happening, generalization became weak. So I had to add a dropout layer. Now you understood why I used a dropout layer there. So now you can see my test accuracy is also improving, and if I see the losses, my losses are also going down. So I find this is a better model. Now, so when I evaluated both, where I first used LSTM 32 number, then I replaced LSTM with a GRU, simply. LSTM cell with a GRU cell, and I recompiled my model. When I saw the accuracy score, could you make out any difference? LSTM gave me an accuracy score of 0.862. GRU gave me an accuracy score of 0.868. Little improvement, but hardly makes sense. Okay. So for my IMDb data set, both of them fit well. So now what did I conclude from this? What did I conclude? LSTM or GRU? Is there any winner for my case study? No. Okay. So from working of both layers, LSTM and GRU, the only thing that I observed in my case study was GRU used less training parameter, and therefore you had memory usage less in GRU when compared to LSTM. LSTM was more accurate on larger data set when compared to GRU while working on the models. This was the inference. So now it's up to the user. If you are working on a larger data set and you prefer to have better and better accuracy, you are okay with amount of memory that you are using, go for LSTM. But you want to go, okay, for a good model, it should be fast. I cannot be using lot of memory, but it should give me a good output. Then I should go for a GRU. Clear enough? So it's up to the user where you will use an LSTM while you are working with sequential data and where you are using a GRU.
Better predictions over sequential data. Do you have any doubts so far?